Chemistry Minions, video number 11 for atoms. We are going to learn how to draw Lewis dot diagrams. This will be important going through for the rest of the unit, or the rest of the year, I mean. We will be doing Lewis dots quite a bit. Bonding, um, organic, we'll come back to them in organic. We will be leaving Bohr diagrams behind. Okay, so a Lewis dot represents just the element and its valence electrons, because that's what we really need to know about as far as how it's going to bond, and that's coming up in 2 units. So we're going to write the symbol for the element, and then we're going to draw a dot for each of its valence electrons. They're going to be on the north, east, south, and west sides of the symbol, and there are rules to adding the dots. The first 2 go together, and then they go one at a time around the bus. 2 electrons max on each side. They want a pair. Okay, every electron wants a buddy. Okay, when I draw my Lewis models of ions, the symbol stays the same. The number of electrons, of course, will change, and I need a charge. So much like what happened in the Bohr diagrams, when we did ions for Bohr diagrams, we changed the number of valence electrons. So that's going to happen here because that's what happens in ions. And we need to put the charge. Looking ahead, each unpaired electron is going to form one bond. And for an ion, it's easier. Ions, when they form, they generally lose all their electrons or gain all the electrons that they need. So whatever that charge is, the number, the quantity of the charge is how many bonds it's going to make. If it's a +2, it makes 2 bonds. If it's a +1, it makes 1 bond. Okay, let's get into it, and I think you guys will see what's going on. So again, you're not going to have to draw everything. I'll show you what the final product's supposed to look like. I'm going to animate my way through so you learn how to do it. So first things first, hydrogen. I'm going to look at hydrogen's tile. I see hydrogen's got its symbol as an H, so I know I'm going to need that. How many valence electrons in its electron configuration? 1. So how many electrons? 1. Okay, now when I look at that, how many unpaired electrons do I have? Look, I have 1 unpaired electron, so hydrogen is going to make 1 bond. Okay, and you know how many a pair is? A pair is 2. You have a pair of shoes, I'm talking about a left and a right, 2 shoes, right? Hydrogen plus 1 ion. I'm going to go right into ions. Hydrogen is H, right? Electron configuration is 1. There should be 1 dot, but it's a +1. I know that +1 means protons are winning. If protons are winning, I must have lost an electron. If I lose an electron, whoop, there it went. It's gone. So I'm not going to have any electrons. He only had 1 and he lost it. He's a +1 charge. And then so check it. Number of bonds. Well, what's the number on the charge? The number's 1. So I'm going to make 1 bond. Okay, we just did an atom. We just did an ion. We got 2 more rows. We finished this row and 1 more row of getting used to what's going on here. Plus, we got to get to first 2 together, 1 at a time around the bus. So that's coming. There aren't enough electrons yet to do that. Okay, beryllium is Be. It has 2, which means it has 2 valence electrons. So first 2 together go up top. Now, when I look at how many unpaired electrons there are none. So guess how many bonds he makes? None. Okay. Now, beryllium ion with a +2, again, beryllium's Be. He's got 2 valence electrons, so first 2 together, but then he's a +2 ion. +2 ion means protons are winning. Then protons are winning, that means I must have lost electrons. I lost both of them. Boom, there they go. They're gone. See? And now I need to put my charge. How many bonds is it going to make? Well, check it. +2 makes 2 bonds. Okay, carbon. Put a special star here on carbon because carbon is special. Carbon defies the first 2 together rule. Carbon and underneath it silicon will do that. So you need to make special note. This element is C. He has 4 valence electrons, but instead of doing first 2 together, carbon's the one that's special. Carbon goes 1 at a time around the bus. North side, east side, south side, west side. Okay. Now looking at it, I see I have 1, 2, 3, 4 unpaired electrons, so carbon makes 4 bonds. This is what you need written there. make sure there's a star because carbon and silicon break the rules. Okay. Now, the next set of practice, we're going to get into those first two together one at a time around the dot rules just a little bit better so you see what's going on. Okay. Oxygen. Oxygen is O. I see I have 6 valence electrons. So again, first two together. Notice there's you could think of there's an invisible line there. And if you need to, in your mind make that dash, do that, and on the end of each dash put the electrons. Well, there's another invisible line here and here on either side, and an invisible line on the bottom. That's where we're putting those electrons, okay? I'm not going to draw that line for you because I don't want to confuse you. We're not into bonding yet, and I'm going to use a dashed line to show that there's a bond. So I don't want to confuse things. It's an imaginary place to hold these electrons. So I need to put in 6. I've put in 2. 6 minus 2 is 4. So I have 4 more electrons I got to get in, but I'm going to go one at a time around the bus. So I'm going to go 3, 4, 5, 6. And now notice that those are kind of on those imaginary lines. Okay. I don't want you to see on the sides that you do them this way. I don't want to see them next to each other left and right. They got to go up and down on the sides, left and right on the top, left and right on the bottom. Okay. That's important. Now, when I check out how many unpaired electrons it has, he has 2 unpaired electrons, so he's going to make 2 bonds. Oxygen minus 2, moving right along. Checking out oxygen again, O with 6 valence electrons, right? Here they go. First two together, one at a time around the bus. But he's a -2 charge. -2 means I've gained 2 electrons because it's negative. That means the electrons are winning. If electrons are winning, I must have gained electrons. So I'm going to put them here and here. I, for teaching purposes, put them in red for you. You don't have to put them in red. You can just put them in there. And notice now that this guy's full. He's got his 8. Notice top, bottom like this, side, side like this. When I try to check my unpaired electrons, there are none. But he needs his charge. What's his charge? -2. So he also will make 2 bonds. Isn't that nice how that works? Sulfur is going to look exactly the same as oxygen because we're going to find that sulfur has 6 valence electrons. So, except for now, I'm going to use element S. 6 valence electrons, first two together, one at a time around the bus. It doesn't matter if you go right or left, by the way. I was going clockwise. You can go counterclockwise. It's okay. As a matter of fact, the first two don't even need to go on the top. They could go on the side. But if you want to get these right every time and to set us up for in the future where those bonds are going to be, this gives me some insight into not only are there going to be 1, 2 bonds, I can see now that the bond is on the west side of the S and on the south side of the S. And that's important for when we start to get into the shapes of the molecules. So there's rhyme and reason to all this stuff. So I want you to pay careful attention to the rules. 2 unpaired electrons, 2 bonds. Okay. Sulfur ion. Quickly go through sulfur, 6 valence electrons, first two together, one at a time around the bus. But that's a plus -2 ion. -2 means I gain 2 electrons, so I got to put those in. Now I get my charge. I see no unpaired electrons, but because it's an ion, I just take that 2, and that's how many bonds it makes. Sodium. Sodium is Na. Sodium has 1 valence electron. There he goes. But he's a +1 ion, so he lost his electron. There it went. Give him his charge. Now I can see that I'm going to make 1 bond because I have a charge of +1. And with that, guys, we just finished the Adams unit. Woohoo!